It's my pleasure to introduce Chris Hebert today. I've known Chris for many years, and like many of our industry here in this area, when Joe and I worked for Entergy, we relied on Chris's projections of what we thought upcoming major events and the weather. We all have to make many decisions before a storm, so we really relied on Chris and his team to make those important decisions. With a BS degree in meteorology from Texas A&M, graduated in 1980, and 39 years of forecasting experience, Chris is the StormGeo's lead hurricane meteorologist and manager of the Global Tropics Watch team. His duties include leading the hurricane team year-round, forecasting tropical cyclones around the world. Besides covering the Southern Hemisphere tropical cyclones during the winter months, Chris heads the marine fog team, producing forecasts for marine fog and port and channel closures all along the Gulf Coast. In addition to that, Chris assists the Storm Watch team in forecasting major winter storms. So you can see Chris is a busy guy. Next slide, please. Last year, I presented Chris with a 10-year certificate of appreciation. Now I would like to take that certificate back, and I would like to present him with another certificate. Please help give Chris a big welcome. And the certificate says, last year it said 10 years of being our speaker. Now it says 11 years of being our speaker, given the most Rotary presentation ever, Chris Hebert, whereas the Rotary Club of Beaumont is over 100 years old, and Chris has been the most requested speaker and has provide more presentation than any other speaker during our history. I made all that up, I guess. Prove me wrong. The certificate hereby expresses our deep appreciation. P.S. Chris, do not predict any hurricane this year. Ladies and gentlemen, Chris Hebert.
Well, good afternoon, everyone. I assume everyone is laughing uncontrollably at your joke there, Vernon. It's just that we can't hear everybody because everyone is muted. So let's get started here, and this will be a different presentation today. I like being in front of a group of people to have interactions, but this is certainly a different way to present. We're going to talk a bit about last year, what happened last year, and then, of course, what's going to happen this coming year. Last year, we had 18 named storms out there, but it pretty much behaved as we expected. A few more named storms than we were anticipating, but we thought the Caribbean Sea would be quiet, and we just couldn't get anything through the Caribbean Sea, which is good, because that's a lot of times where the stronger hurricanes impact the Gulf Coast. We had some tropical storms and one hurricane in the Gulf of Mexico briefly, that was Barry. But most of the activity was centered out here north of the Caribbean Sea, off the southeast U.S. coast. That's pretty much as we were expecting. We did have a lot of short-lived storms last year. In fact, 7 of those 18 storms lasted less than 24 hours. Imelda, which you're all familiar with, caused a lot of flooding, lasted till about 3 hours. About 1 hour as a hurricane for Barry, so some very short-lived storms out there in the tropic this past season. Started out with in May with subtropical storm Andrea for about 6 hours. The Hurricane Center calls this mess out here south of Bermuda a subtropical storm. And we're naming subtropical storms. We didn't name subtropical storms in the past, so that's one reason why we're having additional named storms now. Then we had Barry, which was an interesting storm. You know, it's one of these storms we call a pop-up hurricane in the Gulf of Mexico. Everybody's concerned about these pop-up storms because it doesn't give you a lot of time to prepare. Develops in the Gulf on the 11th, it looks like right here, and then on the 13th, it's already making landfall as a hurricane. But fortunately, well, these pop-up storms occur frequently, about once every 2 years. I went back through 80 years and found 40 such pop-up hurricanes in the Gulf of Mexico. Fortunately, we have computer model guidance that helps us predict when they're going to pop up there in the Gulf of Mexico. And I'll demonstrate here. We had, this is where Barry started in southwestern Kansas. Just a little swirl of clouds there, some showers, a few thunderstorms into the Texas Panhandle. It tracked on east, southeastward, eventually through Georgia, and then moved out into the Gulf. And then southeast Louisiana was when it was classified as a storm. But it wasn't a surprise because even when it was over Kansas, the long-range computer models were predicting low pressure developing and moving off the Florida Panhandle into the Gulf. This is a Tuesday, I think July 2nd. By Friday the 5th, we were looking at an area to watch here in the northeastern Gulf for potential development out there while the Hurricane Center only goes out 5 days. It wasn't talking about anything out there in the Gulf of Mexico. So it wasn't a surprise. We thought something was going to form, and by the following Monday, we issued our first advisory for disturbance over western Georgia. It didn't even have any thunderstorms associated with it. It was just a little bit of an upper level feature that we thought had a very good chance of developing and moving out across the Gulf. We moved it inland south of Lake Charles around 2 o'clock, 1 o'clock, 2 o'clock Saturday afternoon. Eventually, by our advisory 20, it was moving inland about 9 o'clock on Saturday morning. So about 3 hours earlier, a little bit to the east, but for a system that was just a cloudless feature over Georgia, I think that was a pretty good forecast. The Hurricane Center classified it 3 days after we issued our first advisory as Tropical Storm Barry and initiated the advisories on Barry at that point, moving it into the mid-Louisiana coast. It did briefly attain hurricane strength, maybe for an hour. There were some hurricane force winds offshore, but for the most part, it was a strong tropical storm at landfall. Produced some significant tidal surges there across southeast Louisiana. It's a very vulnerable area for storm surge, up to 5 to 6 feet up there in some spots. Then we had the big storm of the year as far as the Bahamas and the East U.S. coast. That was Dorian. High resolution satellite of it slowing down as it moved right over the Bahamas. I had a couple of friends of mine chasing the storm in the Bahamas. One of them is some pictures on left showing what it looked like inside the eye of Category 5 Dorian. 185 miles per hour, moving slowly across the island, just devastated the area. In fact, Dorian is tied with the great Labor Day Florida Keys hurricane in 1935 for the strongest hurricane ever to make landfall in the Atlantic Basin. Not the strongest hurricane necessarily, but the strongest one that makes landfall. It's very rare for a Category 5 hurricane to make landfall anywhere. They usually don't last as Category 5 for very long at all. Just some significant rainfall across the southeastern U.S. as it skirted along the coast, and very significant damage across the Bahamas. This is what about 180 to 220, 230 mile per hour wind gusts will do. It's just like a big tornado, and it sat over them for almost 24 hours. Even produced some strong tornadoes along the North Carolina coast. One at Emerald Island caused a good bit of damage there. So it was a lot of damage, and fortunately it didn't move across Florida. Now, you remember this famous picture of this edited National Hurricane Center track from last September, where somebody, I won't name who, indicated, well, it might well be a threat to, when I tell jokes like this, it's kind of hard to tell if everybody's laughing or not because nobody can talk right now. But if you look out here, you see this projection of the cone out to of western Florida and Alabama and southern Georgia. Well, fortunately for the Hurricane Center, they're only doing a 5-day track on the storm Dorian. They weren't doing a 7-day track because if you look at the model guidance back then, that's what it's doing, taking it right across Florida into the Gulf of Mexico. And by the next day, those are all the various computer models and their additional ensemble runs on the right. I've talked about our track guidance, I think, in previous discussions over there at the Rotary Club. By the next day, well, you know, it's not so far-fetched that there was a chance it could come across Florida and into the northern Gulf of Mexico. So that extension of the cone wasn't necessarily bad. There was a threat back then, and the Hurricane Center's track even indicated that. But like I said, they only produce a 5-day track. They don't have to do a 7-day track, and this is a 7-day forecast guidance here. Eventually, though, Dorian turned north after cruising slowly through the Bahamas by the 31st of August over on Labor Day weekend. Just grazed the Florida coast, about 50 mile per hour winds or so along the coast of Florida, and some heavy rain in the Carolinas, but it did turn and go out to sea as far as the United States. Now, I've been asked a few times in past presentations there at the Rotary Club that aren't we getting more storms than we used to be? Everybody remembers that, well, it just seems like we're getting more storms than in the past. Well, you have to look way back, and if I look back into the way past in 1851, you can see a gradual upward trend in the number of named storms. That's one in green, the hurricanes in blue there, and the major hurricanes in red. But the problem with that is aircraft reconnaissance and satellite data was somewhat lacking in the 1800s and most of the 1900s. We didn't have a way to detect storms out there in the middle of the ocean. Ships would generally try to avoid hurricanes at all costs. They didn't want to go and intercept them and measure their intensity. So it was hard to get a good idea of what we had out there in the tropics before really about the late 1980s with the modern drop sonde instrumentation that the planes had. One thing we do know very well, though, is that when hurricanes made landfall in the United States, and you can see back in the 1800s and first 30 or 40 years of the 1900s, we had a lot more landfalls than we're seeing now in the United States. Indicates about 2 per year down to about 1.5 per year as far as hurricane landfall. So in general, landfalls have declined over the last 170 years out there across the Atlantic basin. And if we look at major hurricane landfalls in the U.S., it's pretty much flat. We had a good number here from the late 1800s to about the early 1960s. Big seasons of 2004 and 5 really stand out, but right after that, we had a 12-year gap with no major hurricane landfalls. Typically get about one every 2 years striking the United States coastline. So there's really no trend there as far as major hurricane landfalls, or if any trend for hurricane landfalls is ongoing, then it's a downward trend. Finally, I think you're very familiar with this storm over there in southeast Texas. A couple of years after Hurricane Harvey hit the lower coast and caused significant flooding, we had Imelda, which was classified as a tropical storm as it moved into the upper Texas coast, and about 3 hours later, it was downgraded to a tropical depression. But we know from past storms like Allison in 2001 that it doesn't take a hurricane to produce a lot of rainfall across the area. This is a radar loop, and you can see the center moving across. I'll follow it with a cursor here. Center's moving across Houston now, moving up to the northeast, and we have bands of squalls beginning to form southwest of the center. Center's way up in here in northeast Texas now. That Thursday, that final squall line that came through, we'll let it loop again. There's a center coming inland right here. Center's tracking northward. But on Thursday, September 19th, a second squall line developed, and it's going to be right up in here. That jumped another 10 to 15 inches of rain between North Houston and over toward between Beaumont and Port Arthur, and that caused additional flooding across the area. But it was these one band after another that streamed across the area on that Tuesday, Wednesday that caused a good bit of flooding issues across the area. Total rainfall, well, same area that hit with some of the highest rainfall in Harvey right over here toward Winnie and Fanette, Texas, about between 40, 44 inches in this area in here. Houston Center, Houston's right down in here. Of course, Beaumont, Port Arthur over here. We're in about 20 inches or so of rain over a 3-day period. It wasn't as bad as Harvey, but it certainly was some significant rain causing flooding across the area. Comparing it to Harvey, we have two graphics here. Only a 4-day graphic for Harvey. We had another 10 or 15 inches fall between Port Arthur and Gallatin Bay that 5th day. But if you compare the yellow areas here, is over 10 inches of rain basically, and the rainfall area for Harvey is much, much greater than it was for Imelda. But if you're in Fanette or Winnie or areas got flooded with Imelda, it doesn't make a whole lot of difference. Water is still water, and you still got some flooded homes, flooded freeways, and a lot of flooded businesses from Imelda. We had, toward the end of the season, we had some unusual features being named. I should say unusual. The Hurricane Center, and this is a big cold front that moved off the Gulf of Mexico. There was a low pressure system along the cold front that they classified as Tropical Storm Olga, which was, in my opinion, a questionable naming. Never named such lows in the past. Nestor, which occurred right before it, was another frontal low that moved into the coast around the Mississippi-Alabama border. So they were naming systems that were a little bit questionable. If we get to the end of the season, Melissa, Rebecca, and Sebastian in the far northeastern Atlantic, not too far from the Azores, were classified. And sometimes we can get systems that are generally frontal type low pressure systems, front wrapping all around here on the outskirts of this image. And sometimes they're cut off from the front and they can become tropical, as was the case with Melissa and Rebecca. Sebastian, a little bit more questionable. The center's right here, but it's clearly a frontal boundary extending out from Sebastian, extending down through here. That looks like a frontal low, but that's one of the reasons why we're having more named storms out there. We never would have named some things like this in the past. Well, let's take a look at what we're expecting for the next 6 months. We're going to look at these factors, and we've seen these before. First of all, the water temperatures in the Pacific, they oscillate from above normal to below normal. When they're above normal, we classify that as an El Nino. And when we have the warmer waters in the eastern tropical Pacific, we tend to have enhanced hurricane activity there. The air rises and it sinks over to the east in the Atlantic basin, and we have less hurricane activity during an El Nino. The reverse is true when it cools off in the tropical Pacific. We have what's called a La Nina, a cooling of the waters. We have less activity in the tropical Pacific, but we don't have that inhibiting factor in the Atlantic. In fact, we may have a little bit of an enhancing factor in the Atlantic basin during an El Nino. So we always watch it pretty closely what the water temperatures are doing there. And this is the forecast. I don't have the April one or the May one out yet. It comes out in the next week, but generally looking at water temperatures cooling in the tropical Pacific over the season and reaching as coolest around the peak season here, bordering on La Nina, which means we might have a little bit of an enhancing effect across the Atlantic basin this season. Forecast is for about, looks like about a 48% chance of a neutral, meaning not quite La Nina, but not El Nino, and just about a 21% chance of El Nino. I don't think it's very likely we're going to see any El Nino during the peak of the hurricane season in August, September, and October. Looking at the water temperature trends in recent days out there in the tropical Pacific, the blues and greens are below normal, are lowering temperatures over the last 3 days, and we see that the water temperatures are generally decreasing over here across the tropical Pacific. And there's some very cool water subsurface that I'm not showing you a graphic of now, so which indicates we're not likely to see any El Nino to inhibit activity this year. Looking at the entire tropics, the Atlantic and Pacific, one thing we can see across the Atlantic is we don't see a whole lot of that blue cool water out there, cooler than normal water. Very, very warm compared to normal across the Gulf of Mexico. The warmer the water is and the deeper that warm water extends, the stronger a hurricane can become. We have that above normal anomaly through the Caribbean and out in the deep tropics. The cooler than normal water is confined to the northern part of the Atlantic Ocean. It doesn't exist down the tropics as it did the past 2 or 3 years east of the Caribbean Sea. Like I said, it's the deep oceanic heat content that makes a big difference here. This is current, and I just got this morning. I was editing the graphics here up until about 10 after 12 this afternoon. So we have some very deep oceanic heat content across the Northwest Caribbean Sea and into the Gulf and Florida Straits here. Compared to last year at this time, it's greater. It's not as great as it was compared to a couple of weeks ago, but we still have more oceanic heat content now than in the past year and in the past several years. So the heat content is there for strong hurricanes in the Northwest Caribbean Sea and in the Gulf this year. As far as the, I've shown you this graphic, I'm sure, in the past. The Atlantic multi-decadal oscillation is based upon the salinity of the water and a current flow from south to north that brings warm tropical waters toward Greenland. It melts the ice, the water gets less saline, it slows down, and then it cools off for 10, 20, 30 years or so. And it looked like we entered a cool cycle in 2013. Historically, in a cool cycle, we have about half the number of major hurricanes than when we were in a warm cycle. But are we really in a cool cycle right now? This is the latest temperature as of March, way down here, minus 1.9. But if you look at the water temperature regime out there, and again, same graphic as before, but concentrated on the Atlantic, we have that cool water up here, which is what the AMO is based primarily on. But what we don't see is the corresponding cool water down here, which we would typically have if this Bermuda high was stronger than normal, as it generally is during one of these cool cycles. The stronger Bermuda high would typically drive drive stronger trade winds from east to west across the deep tropics, and that would bring upwelling of cooler water, and we see a cool anomaly here, but we're not seeing that. That Bermuda high is not stronger than normal, which indicates a more favorable environment than we've seen in the last 3 or 4 years east of the Caribbean Sea. So we're going to have to watch for some longer track hurricanes that are developed here and make it through the Caribbean Sea to the Gulf of Mexico this year. European model, I won't show all the European model data, but basically the past 3 or 4 years, it's been forecasting just brown. Brown is dry, less rainfall than normal, all the way from the Caribbean Sea to Africa. And that's why we had very little activity in the deep tropics east of the Caribbean Sea and from the eastern Caribbean Sea eastward. But now it's forecasting above normal rainfall in the Gulf, a little bit above normal in approaching the Caribbean Sea, and at least normal conditions across the deep tropics, which is, again, a more favorable environment than we've seen for the last several years across that main development region in the deep tropics. Finally, I've mentioned analog seasons before. What we do is we look at the water temperature regime in the Atlantic and in the Pacific, and we look at the general flow patterns all across the tropics and try to find a year in the past that looks like what we're seeing out there right now. And if we find a season that started out with the same conditions we have right now, we could make an assumption that the upcoming season might be somewhat similar in terms of numbers, or more favorable, less favorable for development, or as far as perhaps even the tracks or where they're going to go. And what we see here is that we have some seasons with quite a bit more than normal activity. 7 to 9 hurricanes typically, and 4 to 6 major hurricanes. So we won't talk about the accumulated cyclone energy. Normal's 104. You can see that certainly above normal in terms of activity across the tropics in these analog seasons. And if we look at where some of the storms tracked in these analog seasons, well, we had a good number of landfalls. This is just 4 years. This is not normally what we have 6 or 7 analog seasons. 4 seasons, quite a bit of landfalls and quite a bit of activity concentrated down here in the Northwest Caribbean Sea and into the southeastern U.S. and Bahamas. So we're looking at a potentially certainly more active year farther west across the basin, particularly in the Gulf of Mexico, than we've seen in recent years. So as far as the general signals, what are they pointing to as far as less or more active? Less active, that cool phase of the Atlantic AMO, I don't think that's going to be a factor, because we really don't have that stronger Bermuda high. We don't have the cooler water east of the Caribbean Sea. So I think that's a non-issue. No El Nino, maybe bordering on a weak La Nina, which could be a slight enhancing factor. Very much above normal water temperatures and oceanic heat content all across the tropics. I think it's going to be a favorable environment. The analog years support an active hurricane season, and we have different naming conventions than in the past. We have better technology to detect short-lived storms out over the open ocean than we had in the past. So we're getting probably 3 or 4 additional storms now than we would have in the past, just due to the different naming techniques, naming subtropical storms that we didn't name in the past, and just some very short-lived tropical storms. And finally, my longtime coworker, Fred Schmoody. Fred and I have been working together since 1990 for 30 years. He's our long range expert, and he looks at flow patterns that might help to guide or steer tropical cyclones as they move toward the United States. And we're seeing a general troughiness here across the Mississippi Valley. He looks at the moisture content here to try to identify where the wind flow and the steering patterns are going to be. You see, though, there is certainly some lack of moisture down on the deep Gulf Coast, which tells us that this trough might not quite extend all the way out in the Gulf of Mexico. Where it does interact with the storms, it would direct them up toward the southeastern U.S. But with the weakness down in here, it doesn't protect the Louisiana and Texas coast this year. So let's take a look at the forecast. Normal for over the last 30 years, about 14 named storms, 7 of them becoming hurricanes, 3 of those intense category 3, 4, and 5 hurricanes. We're forecasting 16, so about 2 more than normal, about 1 additional hurricane than normal, 8 hurricanes and 4 major hurricanes out there. Last year we had 3. We're forecasting more major hurricane activity this year. And if we go anywhere with these numbers in the past, we may well increase a little bit. We'll just have to see how the season is progressing. Where are we going to expect these storms? Well, we think that low pressure trough will be there across the central U.S. These areas looking at near normal risk of a significant hurricane impact. And you can see one thing that's very different is that for the past 3 or 4 years, we've had this area here from the Lesser Antilles to Puerto Rico is basically below normal threat level because of the very cool water and dry air east of the Caribbean Sea. But now we think they're at least at normal levels here. And areas above normal, we're in there. All the way from the mid-Atlantic coast down to the northeastern Mexico. I think we're going to see a significant concentration act here toward the Northwest Caribbean Sea and Bahamas or southern parts of Florida this year as far as potential tracks. And all those analog years, some of them moved into the Northwest Caribbean Sea and tracked toward Mexico. Some were picked up by this trough and carried northward. Some occurred later in the season, turned across Cuba and moved through the Bahamas. So I think that we're going to see more activity in the Gulf of Mexico and along southeast U.S. coast than we've seen recently. It looks like a favorable environment farther west this year. And finally, Same name list as in 2008 when Ike reached the Southeast Texas. Same name list as in 2014. Now in 2014, I remember giving my presentation and talking about the replacement names for the 2008 storms, Gonzalo, Paulette, and this one here, which is going to be pronounced Isaias, not Isaiah. So it'll be interesting. Again, we didn't see that in 2014 because we only got up to Hannah in 2014. This year will be our first chance to see the name that replaced Ike. It is Isaias, not Isaiah. So we'll be predicting to see how the media identify this storm. And with that, I've come to the end. And right now, the Blue Angels are just up in the woodland. So we got plenty of time here.
Go ahead, Chris. Let's see if we have any questions.
You can type them in the chat window. I don't see the chat window, but Jackie will find it. Or you can just unmute yourself and ask any question.
Yeah. Do we have anyone that have any questions for Chris?
I can tell they're not laughing at my forecast.
Okay. Well, no questions.
Well, hopefully they avoid us in Southeast Texas and the Gulf Coast in general. We don't need any more hurricanes, but it just looks like it will be a favorable year in the Gulf of Mexico.
One question did come up here, Chris. It asked, why was Ike not considered a major hurricane?
Well, major hurricane classification is based on the average 1 minute sustained wind of 111 miles per hour or greater. Now, Ike was far away from that. It was 110 miles per hour. So they couldn't, you know, for all practical purposes, it was right there, but they just didn't quite, and 110 may have been even a little bit generous as far as what the reconnaissance was reporting at landfall. So it was just, it was borderline, but it was certainly leaning toward the Category 2 and not a Category 3 hurricane as far as its intensity. But like I've always said, it doesn't take a major Category 3 hurricane to produce considerable flooding or rainfall across an area. Ike produced a flooding similar to the Category 4 Great 1900 Galveston hurricane. It doesn't take a Category 3 to produce major damage. And Sandy in 2012, barely a hurricane produced so much damage across the northeastern U.S.
Okay, here's another one for you from Vic. What's the difference between tropical and subtropical?
Well, a tropical cyclone has strongest winds right around the center. And if you can see my hands, right around the center, it tends to have, it derives its energy from heat, from a warm ocean, has a very warm central core. Subtropical storm may be partially associated with a cold front. It may have a very expansive wind field that's much larger than a typical tropical storm would have. The strongest winds aren't necessarily near the center of a subtropical storm, but it has maybe some squalls close to the center that could partially qualify it as a tropical storm.
Okay, here's another. Can you comment on how seismic activity in the Caribbean may be affecting the water temperature?
Well, I don't know how that would affect the surface water temperature across the Caribbean. And seismic activity on the ocean floor, I suppose in small areas could increase the oceanic heat content, but I don't really know much about how that or any extent of any seismic activity heating in the Caribbean Sea.
Any questions? I see from Bruce Walker to everyone. Let's see. I'm looking at the chart at the bottom here where we might have a chat. And I'm just wondering if there's any other individuals that might want to have any questions for Chris. And not hearing any. So I guess, Chris, I appreciate all you've done. I want to thank you, Chris, for visiting us again.
All right.
We look forward to having you every year.
Every year until I can no longer attend, and I'll be on my own nickel, I think, from here going forward with budget cuts and everything. But that's okay. I love going over there.
We want you back.
I'll put it on my list next first Wednesday, I guess, in May next year, right?
You got it. And Vernon will be there making sure that you come.
And hopefully we don't do it this way next year.
You got it. I appreciate that. So let me say to express our appreciation that we are going to make a donation in your name to the Rotary Foundation's End Polio Now campaign that we have done. And we appreciate all that you have done here in the past also. So thank you very much.
All right. Thank you very much for that as well.
Okay. Thank you. I want to thank all who are attending the meeting today. I sure do appreciate all of you being here. And as our tradition, let's close the meeting by saying the four-way test of the things that we think, say, or do. First, it is.
Is it the truth?
Thank you. Second. Third.
Will build goodwill and better friendships.
Oh.
Will it be beneficial to all concerned?
And all four. Thank you all. Have a good week, and go out and connect.
Oh, it
the
did
world.
say that.
So ring the bell.
One other thing to say, I'll make that link available to the PowerPoint for Vernon and Jackie. If someone asked that, I see in the chat window. I'll put it up on my own server and
Chris,
give
a
you-
lot of people expressing their thanks to you through the chat.
I'm looking at the chat now, Jackie.
Good.
Thank you, Chris.
All right, I look forward to seeing you all next year.
Appreciate
I'm gonna look for the Blue Angels.
Bye.
Now.
Take care.
Everybody have a good week.
Thank you so much.
Everybody good? All right, I will end it now if everybody's done. Thank you. Have a good week.